Okay, so interpretation of slope. We saw the rate of change for the expenditures on pets was approximately $1.855 billion per year. So with that in mind, how much will expenditure on pets increase over half a year in billions of dollars? So we know in 1 year it's going to increase that much. So how much would it increase over half a year? Well, since we have a linear thing, if we go up one, or yeah, if we go or up 1.855 billion dollars, that's just going to be 1 year. So what happens is if we only went half year, so now say we only want to go half a year, well, that's just going to be half as much. So now it's going to be one half of 1.855. And so if we take 1.855 divided by 2, that's going to be roughly 0.9275 billion dollars. Okay, so that's how much they'll spend. Now, how much will expenditure on pets increase over a quarter of a year? Well, now we have to think about that. Well, input is only a quarter, so we're going to take a quarter and then times our slope. So we'll take 1/4 times the 1.855. And so if we do that and divide that by 4, basically, we're going to get 0.46375. And again, we had 3 decimal places, so maybe we can say that's approximately 0.928 billion. And this one we can say, well, that's approximately 0.464 billion. Okay. Now, how much will expenditure on pets increase over 3 years? Well, in this way, we're still linear slope. So, if we go 1, it's here, 2 is here, 3 is here. So basically, we're just going to go 1, 2, 3 times what our value was. So it's going to be 3 times 1.855. Well, what does that equal? Well, 3 times 1.855. That's going to give us 5.565 billion dollars is going to be spent on pets over those 3 years. And again, we started with 3 decimal places. We have 3 here, so we'll just leave it at that. Okay. And so that's how we can interpret slopes. We can see that, we're going down from a whole step to half, then to a quarter. And here we have 1 step, 2 steps, 3 steps. And so it's 3 times as much. And so that's kind of how we can use slopes to help us determine different increments, either, quarters or halves or 3 times or 4 times or something like that. Now, this is a very important slide because it's a summary of numerical considerations. So first, a numerical result should be rounded in a way that makes sense in context. So if we look at this example, often this requires the result to be rounded. So a car dealership would sell 201 cars, not 201.4 cars. So, if we come up with a value after you've done a calculation of 201.4 and you're talking about cars, well, you can't sell that 0.4 cars. And so you say they sold 201. Now, it also says the numerical result should be rounded to the same accuracy as the least accurate of the output data given. Okay, so this also requires the result to be rounded. If we had sales for 3 years to be reported to 1 decimal place, then our model estimate for future sales would be needed to be rounded to 1 decimal place as well. Okay, so now we're learning this after we've done those other examples. So now we should probably go back and look at our examples and say, hey, where were they rounded to, and do the same thing. But this is kind of to show you our learning process. We start with one thing, we go to the next thing, we go to the next thing, and then we can refine where we're at and what we can do when we continue on from there. All right, so a numerical result is useless without a label that clearly indicates the units involved. So you notice I put billions of dollars, things like that. So for number 3, it would not make sense for an international company to publish its annual report that net sales were 10.7. Okay, well, that could be $10.7, 10.7 million euros, 10.7 trillion yen, and so on. So you have to really put those units on there, otherwise nothing makes sense. And now the last one we did do, during the calculation process, do not round a number unless it's your final answer. So calculating with a rounded model gives incorrect final results because of round off error. And so only round at the very end. And we saw that one was, what was it, 50, let's see, it was 0.45 was what it was. Where was that? 51.45 is what we ended up with using all the decimals, and when we rounded it, it was 51.54. So that's a key reason why we want to use the rounding here. All right, so maybe we should go look and see. So the numerical result should be rounded to the same accuracy as the least accurate of the output data given. All right, well, the least accurate of the output data given that was these. That was just the 17. And so if our output was only 17, then we would just round this to 51. We wouldn't even put the 51.45. We'd just say 51. That doesn't round up. And so that would be our output would be 51. Okay, so that's kind of a key there. So, and we did that one, and we did units, and so now that would be kind of more in line with this summary. All right, so this table shows the number of people in Europe who use email as a part of their jobs, and we're supposed to find a model for the number of European business email users given the number of years since 2005. All right, so I think with these numbers, I'm going to say, well, that's 0, that's 1, that's 2, that's 3, that's 4, that's 5. So I'm going to realign just because I think using those big numbers are going to be a little more difficult. Now, what is the constant rate of change for the number of European business email users? Well, that's going to be our A, which we have to find. And we need to use the model to estimate the number of business users in 2013, which is 3 years past that. So we want X to be equal to 8. So we want to find basically what's this email user. So we'll call it E of, well, X equals 8. So basically, I need to put the 8 in place of the X. Okay, and we want to find out what does that equal. So again, we're going to use a calculator and we're going to use Excel, and we're going to plug that table into both of them, and then we're going to get a model out. So let's go back to our calculator. And again, I've cheated. I've typed in the values already ahead of time, but I've put them in L3 and L4 now. So this is something you can do. You don't have to always use L1 and L2. You can use L3 and L4, but when you get done, you have to be able to remember when you're typing all the things in, that's going to be your input output. So our X's go from 0 to 5, and we can go maybe from 150 to 250 for our windows. So let's go 0 to 5 by 1. And our minimum, let's do 150. And our max was, I think I said 250. And let's go by tens or something like that. All right. And so now what we have to do is we have to turn the stat plot on. But now what we need to do, our numbers aren't in L1 and L2. So let's go down. Well, this is now L3 and L4. So we need to do second 3. So that's L3. And second 4, now that's L4. And now we can look at our graph here. So now let's go over here to the graph and do, actually, we just get out of here and now let's go here. And so that actually looks like a pretty straight line. So that's kind of nice. So yes, we can use a linear model, and let's do that linear model. So let's calculate the linear regression, which is 4. Now, here again, we have to remember, oops, that's L3, that's L4. Now we can calculate it. And so again, I'm going to write down our numbers here. So that's 16.29142857, and that's 163.3380952. And this is as good as we can get as far as what our values are and when we plug it into our calculator and get it out. So that's a linear regression with this. And again, this is 0.999, so the other one was only 99. So we can tell that this one is a lot better as far as the linearity. All right, so now let's do this one. And so what we need to do first is we need a plot. So let's insert a chart. We're going to do scatter plot. That looks pretty linear. So now let's add that trend line. We'll right click, add trend line, linear. Let's display both of those. And let's move it up so we can read it. And so, it's both of them are 16.29 291 and 163.34. That I mean, they both have the same numbers, and so we look good there. And so now what we're going to do is that's how we can get it again with the Excel as well as the calculator. And so now let's go back and see what the last question. Oh yeah, we had to do the data on uh, 2013, which was the x equals 8. So let's clear this, and we're going to type in our numbers. So we're going to have 16.291428 57 times 8 plus 163.3380,952. Okay, so this should give us our value, which is 293.6695. So we'll write that down, and now we'll go back over here back to our thing. And so now we can just write it here. So let's write our equation down. So E of x we said was equal to 16.2914 x plus 163.3381. And so now we want E of 8, and we said that was 293.6695, and that's million users. And now we look at our outputs, they're all to one decimal place. So we're going to say that's approximately 293.7 million users. And so that would be the last answer there. Okay. Now, is that estimate found by interpolation or extrapolation? Well, again, 2013 is beyond, and so that one is also extrapolation. Okay. And again, does it still fit the model? Well, if we assume that the model continues on after 2010 in the same fashion, then yes, it does. If it happens to all of a sudden, you know, the slope changes and it drastically increases to having a rate of maybe 25.3722, then, you know, this model will not fit. And so we'll have wrong data. All right, so that's all I have for this section.